Welcome back. I'm going to try to start the electron configuration, but before we go through that one, we need to know some rules, how to distribute the electrons between orbitals. Now that I know what's the order of those orbitals, I want to put the electron inside them, but again, I need to follow some rules. The first one that we need to follow is going to be this. Okay, we have electron, and electron, if it's pointing up, we say spin of the electron, the fourth quantum number, it will be plus half. And if electron is pointing down, we say the spin of the electron, it will be minus half. Treat any electron like a magnet. So in this case, you have the north down and south up. While this one, the north is up and the south is down. Okay, so if I put two magnets close to each other, and while the north is facing to the north, in that case, I'm pretty sure those two electrons, they will repel each other. Okay, so two magnets, if two magnets are pointing same direction, north is pointing up, and then both of them, the interaction between them is going to be repulsion. How can I get rid of that repulsion? I can just simply take the first magnet, or the second one, I will flip it. Okay, if I flip this one, okay, so let's say we're going to just simply copy paste this one. Put it close to the second one. So now I have an electron that is pointing up, while this one is pointing down. In this case, there will be attraction force between the two magnets. Okay, this one was repulsion force. So we had one electron, okay, pointing up. This one also pointing up. Okay. Now, in order to put two electrons in one orbital, you need to flip the spin of one of the electrons, and that's gonna be the Pauli exclusion principle. What does it say? It says, for example, pick one orbital like 4 and 4s. This orbital, it has n equal to 4. Okay, that's n. L is going to be equal to 0 because it's an s orbital. So L is going to be equal to 0. What's going to be possible answer for ML? Minus L, 0 to plus L. So ML also is going to be equal to 0. Now let's go after two electrons. Okay, first electron. Okay, and the second electron. It says, okay, you can have the same n for them. So I'm going to put them in like 4 layers far from the nucleus. So n equal to 4, n equal to 4. Next, we're going to put them inside L0, that means s orbital. So I go inside the 4s orbital, inside the 4s orbital. Next, I'm going to use the ML equal to 0. That means our orbital, it will be spherical. So again, we get ML equal to 0, ML equal to 0. Okay. 4 of these quantum numbers are, 3 of these quantum numbers are identical. So instead of 4s, I can easily say L equals 0, L equals 0. Okay. Now, this rule, it says if you decide to go with spin plus half for the first electron, that means your electron will be pointing up. And for the second one, you cannot use this one again, plus half. Why? Because in that case, you will have two magnets that they are pointing same direction. These two magnets are going to repel each other. So what's the solution for it? Solution for it is you have to flip the spin and make this one minus half. Okay, that means the electron will be pointing down. So the Pauli exclusion principle says you can have 3 identical quantum numbers, but the fourth one must be different. Okay, must be different. Otherwise, you will have repulsion and you cannot put 2 electrons in one orbital. Next one is going to be the Hond Hond rule. Okay. And Hond rules like we're gonna have, for example, orbital like P that it has 3 boxes. So this is gonna be say 2p x, 2p y, and then I get 2p z. Okay, let's say you have like 3 electrons. I go 1, okay, and then the second I will flip it here. Now I put 2 electrons inside first orbital. Next, okay, that's one possibility. The second possibility, it will be this. Give me. Okay, the second possibility, okay, instead of pairing them, I'm gonna do this. I will put 1 electron inside each orbital. Okay, I had 3 electrons, so I had 3 electrons inside p orbital. Okay, I can pair 2 of them, put 1 of them inside the second orbital, and the third one will be empty, or I can put 1 electron inside the empty orbit, each orbital. Okay, which one will be the correct configuration? The bottom one, the second one, and this one will be wrong. And the the logic for it is like you're talking about the electrons. Electrons are coming with negative charges. 2 particles with the same charge will repel each other. So why on earth do you want to force them to be in one orbital? Okay, I kept saying this one and Michael in like classes very very like a high number of times, and I said this. If you have a big house and your house has enough rooms, then you should not force your kid to be in one room unless you're damn ready for headache. Okay, why don't you simply just give them one room and make them happy, and everybody will be quiet and you can have lovely love. Okay, it's the same thing with the electrons. Okay, now let's start like in running the electron configurations. And so how about this? I go hydrogen, it has 1 electron, so this is going to be 1s with 1 electron. Now helium, it has 2 electrons, so I go 1s with 2 electrons. So for helium, 1 is up and the second one it will be down, while for hydrogen we had 1 electron and the electron was pointing up. Okay, now when it comes to next element, let's say lithium, it has 3 electrons, so you say 1s with 2 electrons, so the 1s is already taken. Next, you go 2s with 1 electron. Now you have 1 electron in it, and this one will be pointing up. And if you go, for example, to say beryllium, it has 4 electrons, you go 1s2, and then 2s2, up, and then you go down. Okay, so as you see, the first orbital in each layer is going to be s orbital. Now, what will happen if I switch to, boron? And boron has 5 electrons. In that case, I go 1s2, and again, this one, it will be fully occupied, then 2s2, fully occupied. Now I have a new orbital, and that new orbital is going to be a p orbital. And so I will have, give me 2p orbital, 1 electron, and that electron will be pointing up. Okay, now if you switch to carbon, you go 6, this is going to be 1s2, okay, 2s2, and then you go 2p2. For carbon, you're going to put 1 electron inside each orbital, up, okay? And so I'm not going to force the electrons to be in, in one orbital. And that's going to be the own rules. And I'm going to stop the lecture here, and thank you very much.